Okay, for our next lesson, we're going to use a piece of computer-based software to start learning about some electronic components and building some circuits. So the software that we're going to be using is called Tinkercad through a company called Autodesk. So you guys can find your way to Tinkercad. Pause the video here if you haven't gotten that far yet. Once you have, down the side, you're going to see that they have a few different platforms that you can utilize. We want to be clicking on circuits. And you can see here I have a few circuits that I was recently playing with. And what we're going to do though is we're going to want to create a new circuit. So once you select that, it should give you a blank canvas here along with a whole bunch of other parts and pieces. So what we're going to do is we're going to start off by getting a voltage source. So we're going to grab a 9-volt battery, and all we have to do is click and hold, and we can drag it out here. And now we have a 9-volt battery. So it asks us if we want to name it. Well, we'll just call it name 1. That's good. Now what we can do is we can take our battery, and you'll notice here that on our battery we have a red and a black end on it. As you hover over it, it tells you the red end is your positive terminal and the black end is your negative terminal. Anytime you're working with a direct current circuit, which all systems that store energy will store it in direct current, the color coding for that is always red for positive and black for negative. If you start dealing with alternating current systems, there is some changes in color, so be careful and don't mix those up. The next thing we're going to look at is adding in something called an LED. So we're going to click on that and drag it over here. Now it asks us to name it as well, and if we want, we can also adjust the color by clicking on the color, so you can select whatever color you like. Okay. Now, when we go over top of our LED, we see that it has 2 different connection points. So we have one called an anode and one called a cathode. Now, a cathode is just a name for a negative terminal, and an anode is another name for a positive terminal. So if we were to, say, want to connect this LED and light it up, if we connect it directly to our battery, we're going to run into some issues because this battery has quite a bit of energy stored up in it with 9 volts. And if we put that across our LED, it's going to have too low of a resistance level, which is going to mean that there's going to be a lot of current flowing through there. So just to see what that looks like, we're going to connect, hold down our button onto our red wire, and we're going to make a connection here to the anode side of our LED, and we're going to bring a wire around here and connect to the cathode. Okay, so now what we've done is we've completed a circuit. You always need the electricity to start. We're going to think of it flowing from the positive terminal, although there are a variance of theories of which direction electrons flow, but we're just, for simplicity's sake, thinking of it flowing from the positive terminal. It's going to come along through our LED, and then it has to return back to our source in order to complete our circuit, back to our negative. Now, we're going to see something kind of funny happen when we go up here and click Start Simulation. So we have a star across here, across our LED, which if we were dealing with a live LED, that LED would become damaged and wouldn't work anymore. As we hover over top, it says the current through the LED on this circuit is 950 milliamps, which is almost 1 whole amp. And it says that the maximum is only 20 milliamps. So what we need to do then is put something into our circuit that's going to slow it down. So I'm going to remove this wire just by clicking on delete. And we're going to put in a resistor. So we're going to click on resistor and we're going to drag it over here. Now we can change the direction of our resistor just by hitting this little button in the top left, and it'll rotate it for us. Now when we bring in this resistor, we also need to specify how much resistance this resistor offers. So it's named number 1. Its resistance right now is 1, Now, when we look at the units it's measuring in here, that Greek letter omega that we talked about represents ohms, and then there's a K in front of it, which stands for kilo. Now, kilo represents 1,000. So if we click on this drop-down menu, we could put different prefixes in front here. So this would just be a base unit of ohms, and then kilo would mean 1,000 ohms. So right now we have 1 kilo ohm, which is 1,000 ohms. So now we're going to try using this resistor to slow that electricity down, and then we have less current traveling through into our LED. So we're going to now connect our red wire to one end of our resistor, and then we're going to connect the other end of our resistor back to our LED. So now in order for that electricity to get to this LED, it has to flow through the resistor and then to the LED. And again, the job of that resistor is to slow down that current, which in turn will protect our LED. So let's start our simulation now. And now we can see we don't have any stars across there, but our LED is glowing in a nice, beautiful color, and we've now protected it with our resistor.